Let z1 be equal to a plus bi and z2 be x plus yi. Work out an expression for the argument of the product of these two complex numbers in terms of the individual arguments. So if we work out z1 times z2, we multiply the brackets out in the normal way, we remember that I squared is -1, and then collect real and imaginary terms, then we can write an expression for the argument of z1, z2, and that's going to be equal to the inverse tan of the imaginary part over the real part. And let's call that equation 1. We'll return to that equation in just a bit, but for now, let's consider the fact that the tan of the argument of z1 is b over a, and the tan of the argument of z2 is y over x. So the tan of these two things added together, we can use the usual tan of a plus b formula, compound angle formula, and that gives us tan of the argument of z1 plus tan of the argument of z2, all divided by 1 minus tan of the argument of z1 multiplied by the tan of the argument of z2. But we know all of these values because we just quoted them up here. It's either going to be b over a or y over x. So this rather complicated fraction becomes b over a plus y over x divided by 1 minus b over a multiplied by y over x. And what we're going to do now is multiply the top and the bottom by ax. But first of all, to make things perhaps a little bit easier to see what's going on, I've placed the numerator all over a single denominator here. So it's a single fraction on top, and then I've made a single fraction on the bottom as well. So now we'll multiply top and bottom by ax. And that gives us ay plus bx over ax minus by. So what we've just shown, just to recap, is that the tan of the argument of z1 plus the argument of z2 is equal to ay plus bx over ax minus by. But we've seen that right-hand expression before, and we'll come to that in just a moment. So let's inverse tan both sides of the equation we've actually got just here. And what we find is the sum of the individual arguments is equal to the inverse tan of ay plus bx over ax minus by, and we'll call that equation 2. But we've seen the right-hand side before in equation 1. The same thing is also equal to the argument of the two complex numbers multiplied together. So if we equate equations 1 and equation 2, then we end up with the argument of the product of z1 plus z2 is equal to the sum of the individual arguments.